Hi everyone. In this video, we're going to talk about DAX filter functions, which are really at the heart of how measures work in Power BI. Filter functions control filter contexts. In other words, they decide which rows of data are included when a measure is evaluated. In fact, all time intelligence functions are also filter functions. Functions like total YTD, some period last year, and dates YTD, all work by modifying the filter context behind the scenes. In this video, we'll focus on three of the most important filter functions in DAX: calculate, all, and filter. The calculate function is arguably one of the most important DAX functions of all. Not only is it powerful on its own, but it also acts as a container for much more sophisticated and complex DAX formulas. At a high level, calculate is actually pretty straightforward. It evaluates an expression under a set of defined filters. Here's how it works. The first argument is the expression. This can be the name of an existing measure, or it can be a DAX formula that returns a valid measure. For example, you could reference your total sales measure here, or you could write a sum function over the line total sales column in the orders table. Both are perfectly valid. The second part of the function is the filter section. This is a list of simple Boolean filter expressions that evaluate to either true or false. One very important thing to note here: these filters must be simple expressions with fixed values. That means you'll have a column name on the left, and a value or text string on the right, separated by operators like equals, greater than, or less than. For example, you might filter for rows where the cancel quantity in the orders table is greater than 2. Now let's jump into Power BI and see how this actually works with this simple demo. I'm going to open up a Power BI file and create our first calculate measure to filter data. This measure will be related to sales in my orders table. What I want to do here is calculate bulk sales. In other words, I want to evaluate the total sales measure I've already created, but only for orders where the shipped quantity is greater than 100. Let's right-click on the orders table and create a new measure. I'll name this one bulk sales. So we start with bulk sales equals calculate. The first argument is the expression. What am I calculating? I'm calculating my existing total sales measure. Next, we add the filter condition. In this case, I want only rows where shipped quantity, from the orders table, is greater than 100. Once I close the parenthesis, this measure should check out. What I've told Power BI is, evaluate the total sales measure, but only when the shipped quantity is greater than 100. Let's press enter to lock it in. You can see that our bulk sales measure is now defined. Finally, I'll select my matrix visual and place category on rows, along with total sales and bulk sales as values. Now we can clearly see the difference. Some categories, like decor and outdoor equipment, have relatively small bulk sales, while other categories, such as apparel and toys, show no bulk sales at all. And that's a simple but powerful example of how the calculate function works in Power BI. The next DAX function I want to talk about is all. The all function returns all rows in a table, or all values in a column, completely ignoring any existing filter context. The first argument of the function is either the table name or a column name, depending on what you want to clear filters on. For example, you could reference the entire orders table, or you could point to a specific column, such as category from the DIM products table. One important thing to keep in mind is that all does not return a single number. It returns a table, or a subset of a table. Because of that, you'll almost never use all by itself. Instead, it's typically used as a component of other functions, most commonly inside calculate. There is also an optional second set of arguments where you can list additional column names. If your first argument is a column, you can specify more columns to clear filters on. The key restriction here is that all of these columns must be fully qualified. include the table name, and come from the same table. Now let's head over to Power BI and see this in action. Here in my report view, I want to practice creating 2 new measures using the all function. But again, we're not going to use all on its own, we're going to use it inside a calculate function. The first measure we'll create is one that captures grand total sales, or all sales across the entire dataset. This will allow us to later calculate metrics like % of grand total. Since this is a sales-related metric, I'll add the measure to the orders table. Let's create a new measure and name it all sales. I'll use all caps here just to make it stand out and remind us that this measure uses the all function. To calculate all sales, which is essentially the grand total, we'll start with calculate and we'll evaluate our existing total sales measure. Now, when calculate asks for the filter argument, this is where things get interesting. In this case, we don't want to apply filters, we want to remove them. And anytime you want to strip filters away, that's when you use the all function. So, inside the filter argument, we'll type all and pass in the orders table. Since the orders table contains all of the data used to calculate total sales, clearing filters on this table gives us the true grand total. Once we close the parentheses, the logic is simple. Give me the total sales calculation, evaluated over the entire orders table, no matter what. Let's press enter, and there we go. The all sales measure has been added to the orders table. Now, if I select my matrix visual and drag all sales into the values section, notice what happens. We already have our total sales measure, which changes based on category. But the all sales measure stays the same for every row. Even though the filter context is trying to break sales down by category, the all function inside calculate is saying, ignore all of that and just return the grand total. On its own, this measure isn't very useful. But it becomes extremely powerful when we use it as an input to calculate something like % of total sales. So let's add one more measure and call it % of all sales. This calculation is simply the ratio of total sales divided by all sales. The key idea here is that the denominator, defined using the all function, never changes. It always represents the grand total. Meanwhile, the numerator, total sales, reacts to the current filter context. When we drag this new measure into the matrix and format it as a percentage, we can now see what portion of total sales each category contributes. And notice something important here. Even though all sales is used in the calculation, it does not need to be displayed in the matrix. It can stay completely hidden and still function correctly as the denominator. So let's remove it, and there you go. The % of total calculation works exactly as expected. This is one of the most common and practical examples of how calculate and all work together to create % of total measures in Power BI. Alright, so we've already talked about a couple of DAX filter functions, namely calculate and all. Now I want to introduce a third one called filter. By definition, the filter function returns a table that represents a subset of another table, based on a specified filter expression. The syntax is very simple. The first argument is the table you want to filter. This can be any table in your model. The second argument is a filter expression, a Boolean, true or false condition that is evaluated for every single row of that table. Now there are a couple of very important things to call out here. First, filter can handle more complex filter expressions than a standard calculate. One key example is that you can reference measures inside a filter expression, something you cannot do directly inside the filter arguments of calculate. Second, filter is what's known as an iterator function. That means it works row by row by row through the entire table. For each row, it evaluates the filter expression. If the expression returns true, that row is kept. If it returns false, that row is removed. By the time filter has finished iterating through the table, you're left with a new, smaller table that contains only the rows that meet the condition. This is a key difference between filter and calculate. Calculate is not an iterator. It doesn't physically remove rows. Instead, it modifies the filter context. Filter, on the other hand, actively creates a new table by eliminating rows that don't meet the condition. Because filter returns a table, you won't use it by itself. It's almost always used as an input to other functions, such as calculate or iterator functions like SUMX. One last note before we move on: since filter iterates row by row, it can be slower than simpler filter logic. That's usually not a problem for smaller models, but as a best practice, if a standard calculate filter can do the job, use that instead. Now let's jump into Power BI and create a new measure using the filter function. In this example, I want to calculate total sales, but only for products whose product cube, that is, volume of the product, is greater than the overall average size. I've already created this overall average size measure by combining calculate and all. So what I'm really asking is, what are the total sales for products that are larger than the overall average size? Let's right-click on the orders table and add a new measure. We'll name this measure large size sales. We'll start by calculating our existing total sales measure. Now, for the filter logic, let's pause and think about what we're trying to do. At first, you might be tempted to write a filter directly inside calculate, something like product cube is greater than the overall average size. So you reference the product cube column from the dim products table, compare it to the average size measure, close the parentheses, and press enter. But when you do that, you get an error. And the error message isn't very helpful. It says that a function has been used in a true-false expression that's not allowed. What's really happening here is this: you cannot use a measure directly inside the filter arguments of calculate. That's the limitation we're running into. To solve this problem, we'll bring in the filter function. We'll go back to the measure and wrap our logic inside filter. This allows us to define a more complex filter expression that includes a measure. The table we want to filter is the dim products table, because that's where the product cube column lives. The filter expression is simply product cube is greater than the average size measure. Now when we press enter, the measure is created successfully. Here's what's happening behind the scenes. Filter iterates row by row through the dim products table. For each product, it compares the product cube value to the overall average size. If the condition evaluates to true, the row is kept. If it's false, that row is removed. After iterating through the entire table, we're left with a smaller table that contains only products larger than the average size. That filter table is then passed into calculate, which evaluates total sales based on that new filter context. Now let's select our matrix visual, grab the large size sales measure, and place it next to total sales. We can now see large size sales broken out by category, showing us the total sales generated by products that are larger than average. And that's your crash course on the filter function. Next up, we'll dive deeper into iterator functions, starting with SUMX. Thanks so much for watching, and don't forget to subscribe to the channel to support our work and stay up to date with future lessons.